today we will learn some bash scripting. I think if you want to follow me, and I hope you will follow me, then the best way to do is to have two console windows open. So I have one now. If you are working on a Mac, if you just simply push Command T on terminal window, then you will get another tab, another terminal window. So the reason why I think it's good to do that like this is because then you can write the script in one window and you can always try and running it in the other window. So if you are on the course, then that's everything what you will need today, nothing else. So the reason why I thought it would be good for all of you to learn this, that's Mark's usual question, why do I have to teach this to you? The reason is that this will really make your life much easier in many cases. Doing programming in R, doing programming in Python is very useful, and I think it's sooner or later everyone who's doing some kind of bioinformatics has to learn a programming language on a basic level. But doing scripts or doing programs in Bash is quite different. We don't really do big programs, but we do things that are making our everyday bioinformatics work much easier. The good thing with BashScript that the programming environment is always there. So it's actually the Bash shell. It's the same thing what you see when you are logged in. So you have all the commands and a bit more even in Bash scripts. What you have here. So if you say echo hello world, echo is the same command as print in other programming languages. It is printing out what you put after that, and it will say hello world. And echo is always putting a new line character after what you are printing out. If you don't want to put, then you can use -n, and it will here, and without any new lines, it will just before your prompt. In Bash scripts, you are using echo many times because it's always good to do Bash scripts a bit interactive, or at least giving you some sense where it is, how the progress is going. The easiest or the most simple reason why you should do a Bash script, and we will do this. We don't start with that, but we will do this at the second half of this this meeting. Is that, for example, you want to build up your everyday colony sequencing assembly pipeline. If you don't want to use the shovel, but you want to use those steps we learned. So if you want to do every step by step, deduplication, merging, assembly, and all the post-assembly steps, even including proc annotation, for example, then you can put all of these things into one script. So let's go to our Scratch folder. I have a few files here, so that's not bad. If I say ls, of course, I see the file list. Okay, let's make a Bash script here. It's very easy. Just simply, you are starting with a text editor, for example, with Nano, and let's call it first.sh. As I told you before, the extensions in Linux, they are not obligatory, and they don't really tell too much for the Linux machine. So if I just say first or first.sh, both of them will work perfectly the same way. The only reason why I usually put the .sh there, because for me, it's easier. So if you say ls, for example, in this folder, and you see that this is a txt file, then it's probably says something which is text-based inside. If it's a gz, then we know that it's a compressed file. If it's a .pl, again, Linux will not know that it has to be executed by using the Perl programming language environment, but I know that I have some kind of Perl script in this one. So that's why I'm usually using the .sh for bash scripts. If you just hit enter, then you will be in your text editor, and of course the file is empty because I'm just starting writing the file. If you will always use this script on this machine where you know that your shell is a bash shell, then you don't have to do what I'm doing now, but I'm strongly recommend to do this always. It's just one line, which is, again, I said it's not obligatory every time, but it's better to have it there. So the first line of any scripts, and if you're looking at Python scripts, Perl scripts, any kind of scripts, should be the definition how this script has to be handled by the Linux machine. So again, Linux is not judging files by their extension, but actually Linux is judging files based on the first line. And the first line has to tell the Linux machine what is the programming environment, which is in our case is /bin/bash. That's the bash shell. This is the place where the bash programming environment is. The first thing is this hash mark. In many programming languages, also in bash or bash, the hash mark means that it is a command line, which means that it doesn't tell anything for the computer. So if you do it here, not in the first line and not followed by an exclamation mark, everywhere else, this is a command line. The program will not use this line, but the program will use this one because it's not just starting with a hash mark, but it is also starting with a hash mark and an exclamation mark, and it is in the first line. So this is what always should be in your first line of your script. It can be anywhere. You can put comments anywhere. So the easiest bash script is just say ls. Control O, I saved it. So I'm going to the scratch. Again, you don't have to have this. I just let it there, but this is the whole script we need at the moment. The first line with hash mark, exclamation mark, /bin/bash. Then you don't have to leave an empty line here, but I like my scripts not very crowded, so that's why I put an extra line here, but it's not obligatory. It doesn't make any difference. Empty lines are not used by the programming environment again. And if I'm saying ls now, we have the first sh here. It is not green, as we know from previous meetings. The green things are executable. We want to execute this script. So if you say ls-l first.sh, then you can see that there is no X flag anywhere. So it's just the usual chmod u plus X. So we are adding the X flag to the user and then first.sh. If you list it now, then you can see that the X is there and the first.sh is green. Now we can run it. Running is very simple. We just say /first.sh. We ran it, And we have the list of the folder, because that was what we did here. So actually, our first command was executed within the script. Of course, we don't want to do something like this because it's much easier to say ls than saying /first.sh, and it's not colorful as well. So if you want to make it colorful, then you can just say ls minus capital G. And oh no, it's not. Probably not coming through. Anyway, that's not something what we want to do. So that's why I don't really want to go into the details of this one. The first, but the most important thing here is that you can put in any kind of commands. If you have a very long command for spades, for example, where you have to give the different input files and then define the output folder and define the number of CPUs, you just copy that line from your history or copy from your notebook where you recorded how you run, paste it here, and it will run. And if you put them after each other, so you put in first your clumpify, which will deduplicate your raw data, and then the flash, which will merge, and then the spades, then you can just go forward and do all these steps within one script, and you just have to run one script. Of course, you don't want to make a bash script for each sample. So usually you have, if you have something like this, like a small pipeline for assembling data, you want to make it universal. You just want to tell your script that take this and this file as input, maybe use a third thing as the identification of that sample, and then run. So that's what we will do now. Let's assume that these two GZ files, which we have here, one underline 1 and one underline 2, FASTQ GZs are raw data. We want to read them in, and we want to do something with these two GZ files. How can we read in parameters into our script? So actually what I would like to do is, if I say /first.sh 1_1.FASTQ-GZ, so if I give a parameter to my own script, then the script would use this inside and give it to a program. If I simply say this, nothing will happen. The same thing is happening here. Okay? But there is a way to first just print out what we had, and this is very easily just by using the dollar signs. So if I say echo $1 and I saved it, and now I am running my script, then I see that the first parameter, the first argument, is this. If I use 2 parameters, then of course I don't see the second one yet, because my program is only printing out the first parameter. But if you want to print that out as well, just simply say echo $1 and echo $2. If I'm running the script again, then as you can see, it first echoed the first parameter, and second echoed the second parameter. Let me have the chat window open. If you have any questions, feel free to ask anything, of course. There is one more thing, which sometimes can be important, there is a $0 as well. Let's see what $0 is. So if I'm running the script now, $0 is actually the first thing here. So it's the script itself. The reason why this is very useful, because if you want to execute your script from a specific place, so you want to you don't want to let the script to be run from a different folder just by being in your folder where the script is. So let me just go up to the Scratch folder. I can run my script if I say liosh/first.sh. Okay, so I'm not running from the folder where it is, but I'm running from a folder up. And if I'm just running this now, of course there is no $1 and $2, but $0 is the full path of the program I used, or yeah, the full path to the program. But maybe within the script, and you will see this a bit later, you want to be in a specific folder because you know that you have your subfolders there. And if you want to check in the very beginning of your script that you are in that folder, then this is a way to do that. But also you can also, of course, do by pwd to check where you are. But let me just memorize this, that the $0 is actually giving you back the whole full path of the program you are running. Okay, let's go forward. You can put things after each other as well. Like this. To save. If I'm running my script now, then these two things will be just after each other. You can write anything between them. I think in that case, you have to put them like this. So this is also, I think, completely valid, I hope. Yeah, so this is $1, and then I just put in a few dashes, and then $2. The next thing what you have to know is that you can also loop through files, and this is actually very useful. For example, if you are using Proca, so you already have your assemblies, you have them in a folder, but Proca is not ready for working on multiple files. It can only work on one assembly one time. So if you want to run Proca on 100 assemblies, you have to execute those Proca runs one by one, which is not what you should do. But you should make a very simple shell script or bash script to run all of them. Let me just see if I have. Okay, I have a context foster here. I don't have more than one. I don't really want to do Proca now because it's a bit slow. So I will do something else. Okay, I will use these two GZ files. So what we will do now is instead of, no, I won't use them. Okay, we have a context foster in my bins. Okay, now I have 2 foster files in the bins folder, which will be more than enough for me now. So what I want to do now, I want to process all the foster files in my bins folder. I will write a script that will take only one argument or one parameter, which will be the folder where my foster files are. It will list the folder, and it will go through all of these files and do something with those files. Okay, so the first thing what we have to do, we have to make a variable here. As far as I remember, it is happening like this. No. Yeah. We don't need the slash there. So in Bash, when you define a variable, so the list will be a variable inside our script. When you define, you don't have to use the $sign. When you use it, you have to use the $sign. This is a bit confusing, I know, but just try to memorize this. So when I'm giving a value here for the list variable, there is no $sign, but when I'm using it, there is a $sign. Okay. So what is list? The list is everything in $1. You can also say $1 asterisk dot foster. So you only want to see the foster files. And then you will have the 2 things which we have in the bins folder. So we already have a list of files in our list variable. We don't want to print out, of course, the list. So let me just comment this out now. If we want to go through, iterate through the list. And this is happening the same way as in many programming languages. It's the simple for loop. So it's a little bit different from R. What we see, I mean, the syntax is a bit different, but it's quite simple actually. So first we have to give another variable name. This will be the variable which will have the actual element of the list. You know, the for loop will go through your list of 2 foster files or your list of 1000 foster files. So in each loop, there will be only one foster file in the var variable. I think it is done by this, I hope. You don't have to use tab here, but it's a bit nicer if you have a tab, because then you know that you are within your for loop. Instead of using curly brackets, if you remember, maybe you remember in R or in many other programming languages, a for loop is using curly brackets to define what is inside the loop. Here we are using do and done. Do is to open, and done is to close the for loop. So anything after this, if I'm writing anything here that is not in the for loop, because the done is actually there to close the loop. And if I'm just saying echo $var and some dashes before and some dashes after, then it is looking like this. So now there are two separate lines because there were two for loop cycles. In the first cycle, the var variable took the first element of the list, which was this one, and it printed out that element with some dashes around it. In the second loop, it took the second element from the list and printed it out. Of course, if you don't want to print out the FOSTA file name, but you want to use proca, then it's just simply here you say proca and $var, and that's all. Maybe there is other few things you have to say to proca. I don't know. I think maybe you should define like the folder or something like that. Yeah, the output directory is here, for example. But now, if you just simply, I think you can run proca just by the FOSTA file. Yeah, the context FOSTA is here. But the problem is that I think by doing this, it will use the default output folder name, and the default output folder name is always the recent date, which is, if you run two files, then the second one will stop running because it checks for the folder, and if the proca underline recent today date is already exist, it will not overwrite it. So if you want to do this in proca, then you have to use the -out here option, and you have to define the output folder. Usually, the best way to define the output folder is by using your file name. So if you have, if you have hundreds of FOSTA files, probably they have some kind of identifiable name. In my case, this is not really identifiable because what I have in my bin folder, bins folder, is a context FOSTA and context copy FOSTA. But if you think about, if you have Steph Orius underline 1112178 and I don't know what. So if you have your for example, your isolate ID within the file name, then you can use the file name as your output folder name. Let's do that. Of course, it's not really nice to use the whole thing, so probably we don't need the FOSTA. So what I want to do is just want to use anything which is before FOSTA. So how can we do that? So the way how we do this is that we replace, take out. We can do this in many ways. If I simply say cut is a shell command to cut things into pieces, strings into pieces. So here, I want to use the dot as the delimiter. So I'm say that I would like to see the first field. -F1 means that I want to see the first field, and I want to use the dot as the delimiter. And by just simply doing this, I actually cut off the FOSTA. So let's do this within our script. Before I'm running the proca, I will just simply do the echo here. Or I will actually do this. So I will echo that script, what I want to do. But if you do this, it will not run. It will just print out what you would otherwise run. Minus minus out there. Minus minus out there. Yeah, and here we have to use something, and we have to do, okay, so in this case, if I'm just simply doing this, and I'm running my script, then as you can see, we have all of these. We have the bins, for example, here, which we shouldn't have, because the bins folder should, so there should be a folder which is there only for keeping your files there. So, I mean, your FOSTA files, and you maybe don't want to put your proca folders there, but you can. I mean, we can just put it there now. But we have the FOSTA here, so we have to get rid of this FOSTA somehow. Here, of course, we have to do this by using another variable. So let's just try var2, which will be equal to, and I think the way how you do this is by, there are many ways. You can use the cut as well, I think. Let's try with the cut. I think it is done by this. So minus F1 minus D. It is the same I used before. I think this should, oh, and yeah, yes. Let's see. No. Okay. This is the problem here, I think. No such file or directory in line 6. Just give me a second. No. Yeah, the problem is that I'm continuously mixing with this with Perl, so I won't do it with cut. It's much easier. I'm sure it can be done with cut, but I don't think this is the way. So let me just do this in a different way. I hope this will work. Yeah, it worked. So as you can see now, we have the proca and then minus minus out here, bins / contigs. So this will be the folder for contigs FOSTA, and bins contigs copy will be the folder for the contigs copy FOSTA. What I did was, this is very comparable to what we probably used before by shed, or be used in well, usually what we use in Perl is a string replace command. So what we do here is that we are using the var as variable, and we are looking for this string, and we are replacing this string with the one which is here. Of course, there's nothing here. If I'm just saying underline output, then you will see that in each line, the dot fosta from var was replaced by underline output. So the var, which is defined by the for loop, is here, and we are using this syntax to replace this string within the $var, to replace it with this string, and we are putting the results back into var2, and then this will be the way how we run proca minus minus out dear $var2 $var. There is another way how you can, I mean, if you're starting the whole process from the raw data, usually the raw data file is not having the same, the identification, the same identification you want to get at the end. Usually, you know, you have sometimes like strange like this, or I think we have some raw data in raw data folder. Yeah, here maybe this is the identification you want to preserve, but maybe this is not the identification you want at the end. So this is what you can also read into your bash shell script. And I think maybe we can now do the whole pipeline as an example, and then you will see how will I give and build up the chain of commands within the bash script, and you'll see what you can do and what you shouldn't do in that one. Before we go through or we go forward to that one, there's one very important thing, and this is what I want to show you. In many cases, when we execute a proca or a spades, as you remember, we usually, if I just simply say proca beans / context fosta, usually we put this and sign at the end. That's how we put it in the background and then log out and then have a lunch or have a nice walk. And when we get back, we can just simply check if the server finished with the process or not. We don't have to leave the terminal open. It will run in the background. It is very important not to put this into your bash script, and I will show you why. Let me just quickly make another script. Actually, I will do I will do 2 more scripts. Don't have to do this, just please pay attention on it, what I'm doing. Okay, I will do a second .sh. I will start with exactly the same way. I will do an echo hello, and an echo word here, and I will put here a sleep 2. So this sleep 2 is simulating what you should do with a program. So if you have a program which is running for 2 seconds, then you start here, you run the program, and you finish the program here. Okay, Of course, you have usually not 2 here, but minutes or sometimes hours or even days of running of programs. So this will be our second SH. And I will make it an executable program. And I will make third .sh. Again, starting with the same way, and I just say echo. This is the third script. I will save and make this executable as well. Now I will execute the second and third script from my first one. Let me just comment these lines now, because maybe we will need them later. So what I'm doing is just simply say /second .sh and /third .sh. Just think about these two scripts as this one is, for example, the deduplication step in your assembly pipeline, and this one is the flash. So first you have to do the deduplication, and then you have to do the flash. Okay, so if I'm running the first now, flash first, it will run the second and then run the third. So what happened is that between hello and word, there were 2 seconds waiting. That was the sleep 2. That's how you can ask Linux to wait for 2 seconds. Again, if I'm running it, 1, 2, and then, so this is written out by second SH, this is written out by second SH, but there is 2 seconds between them. And this line is written out by the third SH. So everything is perfect. This is what we want. But what happens if you put an end sign here? Because you know that the second SH is running for too long, and you get used to put this there, or just simply copy and paste it there. So if I save this, and now I'm running these 2 scripts, and this is what is happening. So what happened is that the second .sh was started, but then put in the background, and the third was immediately executed. So before the second finished, the third was executed, and that actually finished as well. So this is extremely dangerous, because if you do the deduplication step here and you put it in the background, then there won't be any output files for the flash to work on. So you should never put any jobs in the background within your bash script. Of course, you can put it in the, you can put the whole bash script in the background. So instead of putting in steps, again, never use this within the script. But you can easily do this. So you have the whole pipeline. Now you know that, okay, step 1 is running for 20 minutes, step 2 is running for 30 minutes, and you have a 1.5 hour run and the checkam, and then you have the other one, so on and so on. And you want to put this whole process together, which is now in your SH script in the background. So this is perfectly okay. It is working. It got the process ID, and it's also finished. So if I'm now, if I make the waiting in second to 22, So this is 22 seconds now. And I run it again in the background. And it's running now. I have my console. I know that by looking at jobs, I have my first script which is running for 22 seconds. I don't have it in my top list because there is absolutely no CPU used. It's somewhere there. It's just not at the top. And after a while, yeah, now the 22 seconds finished and the whole script is finished as well. But of course, the line from the third.sh is after the second sh, so everything is running well. Okay, let's do it for a real word problem. Let's make a very simple sh script for you to help running an assembly pipeline step by step. For that, I think, just simply open the that cheat sheet I made to you here. Bioinf course, material, and we have the de novo assembly cheat sheet here. Okay, you can put the file integrity check into this script, but maybe that's not the best idea. I think the first two steps should be done before you run anything. So you can, for example, do an MD5 sum. I don't have to do it with a for loop because the files are usually in a TXT file, but you can do, for example, a fastqc with an sh script on many fastq files at the same time. Oh yeah, there is one more thing. If you want to use, just show you something. So here we have, it's not the nicest example. Usually the fastq files having exactly the same name or beginning, and then underline 1 fastq.gz and underline 2, which means that this is the same, the same row data, but the two read pairs. It is usually much easier just to read in this one and make the second file name from the first file name just by simply replacing this 1 to 2, or replacing this one here, replacing 2 to. It's the reason why it is a bit better, because then first of all you don't have to give as many parameters. If you want to give both file names to your script, you have to put in both file names. If you just give this one, and the program is automatically creating the other file name from this one, then you have to write a bit less. So let's start with this. So let's start with the program, and now I'm just using the first sh. You can delete lines in Nano by pushing Ctrl-K. Whole line can be deleted. Okay, so also if you are starting writing a script, it's always good to start with some comment. Okay, this script will assemble bacterial genome from row sequencing data. The reason why I'm putting this here, because if you start making your own scripts and you are writing 5, 10, 20 of these scripts, and you go back to your folder a year later or 2 years later, you maybe have no idea what your scripts are doing. But if you have your comment, your usage, your main purpose of your script in the first few lines, then you just look into the line, your script with less or with the head command, print out the first 10 lines and you will see what is it used for. It's also good to have the usage here. So the usage is /first.sh. And then you have to give the parameters here. Of course, not the parameter name, so not exactly the file names, but those things what you will know later when you want to use this script. So I usually do it somehow like this, that first mate of sequencing file, sequencing data, and the second parameter we will give is a sample ID. Okay, this is how our program will work. If you want, you can also say here that script is using I think it's much more argument. And then this is how you use it. So the first thing what we have to do, we have to create the second file name from the first file name, and we will do it the same way as we did here. So let's just say first file equals to $1 and ID sample ID equals to $2. Okay, this is where I'm reading in the first argument to this variable and the second argument to this variable. The reason why I'm doing this, because it's much easier to work with variable names that has some kind of meaning. The $1 doesn't have any meaning. We know that it's the first argument in our script, but when you will be in your 15th line, you don't want to use $1 anymore. You just want to use $first file, and we have to make our second file, which is done by the same way how we did this. So we are replacing first file, and we are replacing yeah, the problem is that you can have files with FOSS-QGZ and you can have files with FQGZ. Okay, so it's not really easy to, I cannot see that, okay, replace underline 1 with underline 2, because there can be another underline 1. For example, in this file name, we have underline 3, but maybe there is a file name with underline 1 here. So I don't want to replace all underline 1s to underline 2. I only want to replace the last number within your file name before the FQ or FOSSQ.gz extension. So what I will do is I will replace not the FOSSQGZ, but F and star GZ, which means anything. So it will look for underline 1 dot F anything dot GZ. Okay, and I will replace this. I'm not sure it will work like this, but let's try. You will see. these things are all commented out, so they won't do any harm. So I'm only giving the first one here. I won't give the $2 now because it's not processed yet. Oh, it worked. So it's just simply replaced the underline 1 with underline 2, and the file name is perfect. So we have the two input file names. The first will be the first file, and the second will be the second file. We don't need this anymore. And we also have the sample ID, which we will give later. So the first thing was this clumpify thing. Again, just simply copy and paste from here. Now, of course, it has to be in one line. And we have to delete this from here. But this is extremely very simple because, of course, we don't have the clumpify sh here. So that's, I'm not sure we have. No, we don't have it here. So that's why we need to put the full path. But the in will be our $first file into. So this is the two input files. Again, if you don't remember, clumpify is doing a deduplication on the data. So it will filter out those row reads that are having exactly the same sequence, row read pairs actually. So for example, if you do a few PCR cycles before sequencing, then there is a chance that you are sequencing exactly the same PCR product. And to reduce the amount of sequencing raw data, you usually do this deduplication step. Of course, you are only doing this if you are doing genome sequencing. If you are doing RNA sequencing, you don't want to do this because in RNA sequencing, having more than one from the same entity has a meaning, because sometimes you are looking for expression, not just the sequence. So yes, if you want to quantify what you are sequencing, you shouldn't do deduplication, but otherwise you should do. This is the second file. Okay, so here, of course, you may ask that why do we have to do this in a bash script? We can just simply give the first and second file for clumpify, but the reason is because we will have all the other comments in this bash script as well. And then we have to give some kind of output file name. The easiest is just to simply say, here we can use the sample ID variable, but here, I'm not sure that this is working. Let me just try. The good thing is if you don't know that something is looking like that, what you want to look like, then you can just simply say echo and try to echo what you want. What I want now is to use the sample ID as the beginning of the file name and then underline deduplicated dot FQ or FASTQ or something like that. So I would like to use $sample ID underline or dot. Let's be under ID underline dedup dot FASTQ. Let's see what will happen here. I'm not sure that it will like it because maybe it will think that this is the variable name. and not just this. If it thinks that, I think we can just use a dot here. Let's see. Yes. So we will use dot here. This way, this will come from the variable, and this will be just put after the variable. No, it's not. Let's ask Google. It works like this. So we have to use this way. So if you use your variable name here, this is the syntax you should do. Yeah, I know what's the problem. There is no simple ID. That's the problem. One. Yeah, this will work. Okay, so we gave the first file name and we gave the simple ID as the second argument. So this is what we have to put in. So input first file, input to second file, output one will be sample ID underline one. We can use underline now. Underline one fast queue. The out two. I know this is a little bit, it looks a bit complicated, but it's actually not that complicated, and it will really help you later. And here, this is number two. So what we only do here is that we are reading in the files, and then we are outputting two files based on the sample ID we are using. The good thing with this one is if you start this script on one of your assemblies or one of your raw data, you can start, and you put it in the background, you can easily start another raw data assembly on another pair of raw data, because you will give a different sample ID for the second one. You know, sample ID should be always a unique ID, and this way the files will not be in conflict with each other. So that's why we cannot really just simply give a general file name here, because if you just say that, okay, all the output will be named raw data underline dedup underline one and underline two dot fastq, and you run the script in multiple raw data and you are doing multiple assemblies, then they can be in conflict with each other. Sorry. So in this way, the first command is done. This is the first step in our pipeline. You can, again, if you want, I won't need this one anymore. You can just put a comment here. So first step is deduplicate data. Okay. I'm not sure we'll need the for anymore, but Okay, the second step, I think it was merging. Yes, I'm actually copying things from here. No, I'm not copying. Oh yeah, we will need one more thing here because the Clumpify is not running from anywhere. If I'm trying Clumpify sh here, there is no command like this. It is in our home directory. So if I'm saying /home/ I'm saying Ubuntu, you have to say bioinf and bbmap and Clumpify, then it is running. Of course, there is no input now. So that's why we see the help. But what we have to do, we have to put this whole path into our script because we don't know where we are running the script. If we put there the complete path, then there shouldn't be any problem. And this is just simply like this. As you can see, the end of my line is now disappearing. This is one of the problems with Nano. Okay, this is not the whole line here. Okay. So second step is merge overlapping reads. We are using the flash for this. Again, if you say flash here, oh, it is working. So we don't have to give the full path. Flash is already known by your environment. If it's not, I think it's okay. It is installed in in the Miniconda. Probably it was installed by the shovel pipeline for me. If it's not installed for you, then you can use the flash from your home directory. We have it in /home for you. It's bioinf for me. It's Ubuntu, and we have the flash 1.2.11 blah 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 flash there. So you can just put this whole path there. This is what I will do. Okay, and if you remember, Flash is working this way. So Flash is requiring the first deduplicated file and the second deduplicated file as an input. So what you only have to do is just simply copy everything from here. This is the first file name, and this is the second file name. Okay, so the output of this program will go into the input of this program. It is exactly the same file, two files. And again, this is why I cannot put an end sign at the end of this line. This is why I cannot put the Clumpify in the background. Because if I'm doing this, then there won't be any output files for Flash ready to process. So this has to be finished, and then the next step, which is the Flash, can start. Of course, we usually have a few options here. So if you go back to the Flash usage, as you can see here, oh, this was the Clumpify. You can see with the help, the usage is this way, but we also, I think maybe it's at the very beginning. Yeah, so flash, then the options, and the first made file and the second made file. So in the options, we usually have a few things which we change on the default options. As you can see here, you can use the -t and numbers to run it in multiple cores. If you are doing it here on this bioinformatics core server, this should be -t4 maximum, because that's the maximum CPU number we have here. -M30, which is a bit more strict option than the default. This is the minimum length of overlap in the middle of the two reads. So if you set -M30, then you are requiring at least 30 base pairs overlapping. I like this because this is a bit more strict and more reliable. Yeah, it's here. The minus capital M is not extremely important, but the -O is very important. Again, if you run Flash like this, it will create 3 files, 3 standard files. It's here, output, not 3, actually 5. But it will look like out.extendedfracs fosq, out not combined 1, not combined 2, and the 2 histogram files. The problem, if you leave the Flash to produce the default file names, then again, if you run this pipeline at the same time for multiple samples, then they will overwrite each other files. So that's not a good thing. So that's why you should replace this out with some kind of prefix. Luckily, we have the sample ID as prefix. So the easiest thing here is just say -O $sample ID, which means that instead of having out.extendedfracs.fosq, we will have the sample ID, which you give as a sample ID, not the word sample ID, but the something what you gave as a sample ID, .extendedfracs.fosq. Okay, I will do the next one. Yeah, I think I will do the next one, and I will maybe the mesh as well. And I will ask you to put in the next yeah. The checkm is a bit more complicated, but it is doable. Okay, let me just do all of them. But if you want some challenge, I can leave the last 1 or 2 steps for you, and then you can just put it in, and if you want, you can just send it to me if you want to check if that was okay or not. But the next step in our pipeline is the assembly. So again, a comment just to know what we are doing. Third step is the de novo assembly. Here we will use the spades. As you can see here, this is how we should use it. So I will just, again, copy this from here to there. Again, this is in multiple lines, so it should be in one line. And we just have to rewrite all the file names. Again, we have to check if the spades.py is working like this or not. It is working, so we don't have to put the full path there. I just wanted to show you something with the spades. The spades is a Python script. This is why it is .py. If we look into the file, look at this. the first line of the file, hash mark, exclamation mark, /user/bin/env Python. The first line tells Linux that it has to use the Python programming environment. Okay, the same way as we said the bin bash. If you look into my test.pl, which is a Perl script, of course it's not. If you look into my other Perl script, this one, then you will see that the first line is hash mark, exclamation mark, user bin Perl. This is telling the Linux that it has to be compiled and executed by using the Perl programming interpreter. That's why you will always need this in the first line of your bash script. Right, let's use the spades. So the -1 is the unmerged made file 1, which is the output of Flash. Let's go back how the output is looking like. It was somewhere here. So it will look like this. But instead of having the out there, we will have, of course, the simple ID because we gave it as the output prefix here. So this is how the output file looks like. Of course, this will be replaced by the sample ID we gave to the program at the very beginning as the second argument. I'm -o. Just let me recheck that -o. Yeah, that's the output prefix. Default is out, but instead of out, we are using our simple ID. And we have the same thing here as the made file 2. Just one little difference here, that this is 2. And the merged file. This is how, I think this is something like an extended. If you go back here, the merged reads will be in this file, extended fastq. I'm just using this because instead of the out, we are having our own output prefix, which is the $. Okay, so now again, the spades is using the output files from the mesh, reading it in, and we'll do it here. For the output folder name, we can use again the simple ID. Underline assembly. Sorry, it is again wait here. I cannot really put this into multiple lines. If I'm doing this, then it will be much smaller, but maybe you can see the whole line. Yeah, you can see the whole line now. And you can maybe remember that this is -T4 means only that we are using 4 CPUs again. -M20 means that we are maximizing the memory usage of spades to 20 gigabytes. And -- careful is a very useful option if you want to turn on the error correction of spades. And that's all. Again, spades will run. And the final step is mesh. Again, Then we have to check if mesh is working without the whole path. It is working, so we don't have to put the full path there. Is species identification. There are a few things we have to rewrite here. As you can see, I'm just deleting the quotation marks because we don't need them. So as you can see here, we have the path to RefSec genomes K21S1000.msh. Of course, we don't have a file like this. We have this file, I think, in stretch/databases. No. If anyone knows where this file is, then just please tell me today. Check plots. Maybe it's in the mesh directory somewhere in my home. Oh, it's actually in my home. Okay. So this is my home directory. And here I have the RefSec genomes K21S1000.msh. That's the database for mesh. So I just have to delete this and put this here. And now I have the full path to the mesh default RefSec database. Of course, you can replace this one if you have your own mesh database. And here we have to put in the config FOSTA file. So if you do a space assembly, I think I have one in my folder. Yeah. So this is actually not, this was done by Shovel. But as far as I remember, we have a context FOSTA file. Let me just quickly check. The HPC that we're only using the problem is that I'm always deleting. I think there is so here we define the output folder with this one. So in this folder we will have a context.fasta, as far as I remember. So what we have to do here is just simply copy this, paste here, slash. So we have this folder, and within the folder we have a context.fasta. Of course, if we do it like this, this will just print out the things into your screen. But when you run this script, you want to be away from your computer, so you just want to put this into a file where you can see what was the output of mesh species typing. So again, you are doing a simple specific file and .txt. Okay, so this will run mesh. This will sort the hits by their p-value. Yes, p-value. So the highest p-value will be the last one, and the highest p-value is the highest probability that that species is the good species. And we are using tail just to print out the last 10 lines. So in your output txt file, you will have probably just one good hit at the very end. But if you have, for example, a mixed assembly, then you can have multiple genomes at the end. And that's all. And I will do the checkm for you because that's a bit more tricky. But otherwise, you can do the proc, I think, easily from here. And it's also about time, slowly. And you can also put in the abricate, yeah, or oh yeah, the most important thing will be the cleanup. So, okay, I will do the cleanup here. So you have your raw data, which you of course want to preserve. Never ever delete any raw FASTQ files, but you don't need the duplicated FASTQ file because you won't work it with again. You don't want to work with it again. If you want, you can just simply remake it. You won't need the outputs of the flash. As soon as you made the de novo assembly, you can delete all these temporary files. So the first thing is that you want to delete these files. I'm going to put an asterisk here. Asterisk. So this means that it will delete dedupe 1 and dedupe 2 as well. Okay, so we removed the outputs of Clumpify. Now we are removing the outputs of Flash because we don't need it anymore. Again, here I'm putting this, so 1 and 2 will be removed, but this is only the two not combined files, so I have to remove the extended FASTQ file as well. And from the assembly folder is usually quite a big. The states are putting there a lot of temporary files, error-corrected FASTQ files, a lot of junk. So what you only need from there is the context FASTA file. So what you can do is just move it out from there. So the easiest way is just to move from the assembly folder the context.fasta here. The dot means that you are moving it here. I'm just writing in exactly the same comments I would write into a command line, of course, just after each other. So this is what I'm moving. From here, I'm moving to here, which is the folder where I am at the moment. And as soon as I moved out the context FASTA, which is the important information for us, you can delete the folder. I'm using -F, which means that it is forcing the rm command to delete, so it won't ask me that, are you sure that you want to delete? With -F, it's just delete the files, but you have to use -RF if you are removing a folder. You can only remove files with rm minus f. If you want to remove folders, you have to use rm minus rf. As I told you before, this is one of the most dangerous commands on a Linux machine, because you can easily remove a lot of usable things as well. So be very careful what to write here. But what I'm removing is just simply the assembly folder. Of course, nothing is happening at the moment because this is just in the script, so I haven't executed the script yet. This is also good that you can always go through your script again and again and be sure that you did everything well. If you are not sure that all the file names are good like this, then you can just simply put echo here and put the whole thing into quotation marks, and instead of running the whole line, it will just print out the content of the whole line. So it's always a good thing to look at what you will do before you do it by using echo. Okay, so we did the cleanup, and as a final step, we will do the checkm. So as you remember, checkm is not working by default, because checkm, it's actually checkm, but even if you are doing this, it's not. Why is it working? Again, I think some other program installed. Checkm. But I think it wouldn't work well. Maybe it's running now, but I think there is a need for other things as well. If you remember, we always, and it's also within this tutorial cheat sheet file, you have to use the dedicated environment for checkm, which is the py27. So before you run checkm, you have to activate the py27, conda activate py27. For me, there is no py27 anymore, probably because I deleted it. For you, I think you have it. I think with conda, I did something with my checkm. Create environment. Yeah, I don't have the py27 anymore. I think as a bi-infuser you will have it. So I would make it for myself later on. So what you have to do is again just the same as you would do in the terminal. You first activate your conda, then you do your checkm, and then don't forget to deactivate at the end. I think it's just simply conda deactivate. I think so. And here you will have to checkm quality check. And here we are putting in this whole line. Okay, so we are running the lineage workflow. We are using an extension of FOSTA, and we are using a reduced. Yeah, the problem is path to the folder with config FASTA file. So we have our config FASTA in the folder where we are working at the moment. So maybe we should move it somewhere else. Here we can have a folder final assemblies. What if we don't have this folder yet? Then we have to create. And here you can learn one more thing. So if you don't have the folder, you want to create this folder because you want to move this file into this folder. But if you have that folder, you don't want to recreate it. So here we will do an if, and what we do is we will say f exclamation mark minus the final assemblies, and I will tell you soon what I'm doing, and I hope I'm doing it well. Yes, this is the way. And semicolon, then yeah. As we did in the for loop, we started the for loop with a do and we finished with done. If you do a condition in bash script, then you are starting with an if. You open the if condition with then, and you close it with phi. So it's not a mistype. It is closed by phi. And then you do something here. So what I did here, the exclamation mark in many programming languages, also in R, in Bash, in Perl, in Python, means the opposite. Minus D is checking if a directory is present. So what we do here we have a directory name. We are checking if it is present. And if it's not present, this is why we have the exclamation mark here, then we create it. MK here, final assemblies. Okay, so we made the directory here. Of course, if it's done, because you already had assemblies before, then it won't create, because then it detects that it is present. And if it's present, then this is not true, because this is only true if it's not present. So if it's present, this is not true. So this will not happen. Right. So we have the file in the final assemblies. Right. I'm just thinking that maybe this is not the best way to do this, because then it will do the checkm for all the assemblies we have in the final assemblies folder. Okay, I will do something different. Sorry, I'm just jumping here and there. We will have a temporary assemblies folder. We will move the FASTA file out of the assembly folder to these temporary assemblies. Temporary assembly is only there to run the checkm, and as soon as the checkm is executed, then we will move it out from the temporary folder into the final assemblies folder. Okay. So here we leave the FASTA, we are leaving the minus reduce 3, but we are changing the path to the folder with the config file. It's not perfect even now, but I will think about how to make it perfect. But this will be the temp. Oops. temp assemblies, assemblies, and this will be the results output folder name. Let's just give this again. This is an output folder name, so this should be this underline checkm output, and we know that checkm is also producing a text output, so we can put that text output into a file and call it as checkm log for this particular sample ID. So this is how it is done. And then in the final step, we are moving out our context FASTA file from the temporary assemblies to the final assemblies. Right. Whew. Yeah, this is a nice big program. I think I will finish here, and I'm very happy to have all your extensions in for the script. For example, putting in the proca after here, somewhere here, or putting in abricate if you want to check your assembly automatically for different genes. But now I think that's all. I hope it is logical, that you just really copy and paste all your comments, what you did in your command line before. So the easiest way is actually just simply look at your history. You know, you always have your history on. You can say history, or you can look at the file, which is the slash in your home dot history. And if you look at this file, you will find all those lines that you used before to run your first mesh. When you run, yeah, for example, here we have a clumpify, which we did long time ago. Or later, here we have the space we did well before. So just copy out from here, and you just rewrite the file names. And always, of course, try to use some kind of variable which you can carry forward the whole script, which will actually replace parts of your output file names with the sample ID you want. Is there any question? I'm also very. I mean, this is maybe a bit too much for just one meeting, but if you start experimenting with bash scripting, you will learn it very quickly, because most of what you have to do is already there in your history, and you just have to practice with these variables. But again, if you are not sure that this variable is really what you want to do, then just simply do this. You can always do this echo and here. And let me go at the end of the line, which is not working by just clicking there with the mouse. If you do this, you will see this whole command written to your screen instead of executed. And if you see that, okay, the variable names are okay, everything looks good, then you can just simply delete the echo and run the real script. So I would do that if you are not completely sure that you made the variables well, or if you, for example, do some kind of condition here. You can do many different conditions. If you say -f, it will look for a file, if the file is present or not. But you can also do any kind of condition here. Okay. Any questions?
Thank you, Laj.
Okay, if there's no question, I will stop here. And again,
Yes. Hi, Laj.
yeah,
Hello.
Yes, sorry.
Here, if I want to download from some files from Ncbi and I have to give input for that, how script?
Yeah, so the best way to download files from NCBI at the moment is because NCBI actually published or made a short program, which we already used with Emily. It has a few problems, but it is actually quite usable. Let me just see if I can show you quickly how it works, because it's actually very useful. Databases, data. This will be like 5 minutes only. NCBI command. I think if you look for NCBI command line tools, yeah, this is the one. Get started with datasets. This is what you have to look for. This is the program, datasets tool. The good thing is that I can actually download this and put it in one of the main folders of the bioinf server. So instead of
I think Lajos, your screen is not visible.
Sorry. Yeah, I finished the screen sharing. Okay, so what I did was I was looking for only like NCBI command line tools in Google. And here I have a hit with get started with datasets, NCBI NIH. This is the program they made. And this is actually a very useful program if you want to download genomes, for example, genome sequences, because what you won't need, you will see this later here. What you only need is just this GCF identifier. So if you know the GCF identifier, you don't have to look, because in NCBI, sometimes they are in some very special FTP server on a strange folder. They are not all in one folder. They are in separate folders, also in the EBI server. So I think it's way much easier just to use this program. What I can do again is that I can download the program and I can put it into a folder where all of you can see it. Yes. Let me just do, so now I have the data sets here. I will modify it. The data sets is now only executable for me, so I will make it executable for everyone. And what I'm doing is that I will copy this into snap in user local games, user bin, user has been, yeah, this one, user local bin. I will copy it here. This folder is visible for everyone. Datasets to here. I need the sudo rights for this one. Which means that now anyone can use the datasets even if you are logged into your server. But if you want to do this on your own server, of course, you have to download datasets and you have to run it from the place where you want to use. But on the bioinformatics course server, datasets will be accessible from anywhere. And as soon as you have this, you just have to have the GCF identifier. If you have multiple identifiers, you can put them into a file. it is here. Download assembly. So this is the main command if you want to download an assembly. I won't include the GFF. Oh no, this is actually a human genome. I don't really want to download the human genome. I will look for some prokaryotic genomes soon. But if you have a simple text file with the GC and GCF IDs, then you can just simply use datasets download assembly minus input file. And then it will download all the assemblies within your input file. So let me just show you. I think I have in the Scratch folder. Here we have one, yes. So if you use the datasets, cd data, and I want to use this GCF, I'm just simply say datasets download assembly, and then the GCF number, and it will connect to the Ncbi server. It will create an Ncbi dataset zip file. So you have this one here, which is new. You can always redefine this file name. So this is the default file name. But if you look at this with the minus file name, you can give any kind of file name. So if you want, if you, for example, you want to download all the Staphylococcus genomes, then you can say minus file name Staphylococcus genomes.zip, and you of course have all the Staphylococcus genome identifiers. I think you can also download by text ID. I can imagine that you can download by genus. I haven't done it yet, but I think you can. You just have to check what kind of different functions or options the program has. But what you have here is, so you can just simply use unzip Ncbi datasets.zip. So as you can see, now we have an Ncbi dataset folder. In that one, we have a lot of different files. Again, we have a few MD5 files, which are very good. If you remember, these are the files which can be used to check the file integrity, if the sequence is really what it should have. So if you look into the manifest MD5 txt, then this is actually having the MD5 hash for our genome. And if you say MD5 sum manifest, then it will check -c, sorry. That's for checking. Then it won't check because it's strange, because the files are there. I think the problem is with the file format. We have a \r at the end of the columns. So this is probably a Windows-based file and not a Linux-based file, but anyway, you can check it if you want. If you simply just say cat manifest, then you will see the hashes here, and then you say MD5 sum is, okay, we only have a data folder here. And inside that, okay, that was the problem. I know now. Anyway, if you make the MD5 sum for the FASTA file, you can just compare this string with this string. This has to be, this is what they created before they provided the file to you. And if string is exactly the same as this one, as far as I see, it is the same, then it means that what you downloaded is the same file as they have in their server. Okay, that means that during the download, there wasn't any error in the file. And so actually what you have here is a lot of GCF files. If you give a list of GCF identifiers, then you will have all these files in the data folder. Okay, we only have this one because I downloaded only one file. But this is actually way much easier to download files with this than with writing your own bash script. But if you want to download anything with bash script, you just have to use the wget, the same way as we used before. Just put here that if you first want to download any files, then you just have to say wget and here the URL. It will work exactly the same way as we did before many times in command line. Okay. But again, go on this website and learn how to use the datasets program, because I think this is a very useful tool. You can also download GFFs, not just FOSTA files. So if you say this one, you know, I only said datasets download assembly and the GCA or GCF identifier. But if you say minus include minus GFF3, then you will have the annotation file as well. If there is an annotation file, of course.
Thank you, Rajesh.
You're welcome. Any other questions? I'm also very happy to review your script. So if you feel that your life would be much easier by doing some automation, and you are not completely sure that the script is good as it is, then I'm very happy to look into the script and check if everything is okay. I really strongly recommend to start using bash scripts. It's for your own help, believe me. Right, if there is no other questions, then have a very good weekend. Happy birthday again for Ibrahim for